Use a calculator to simplify the next ones. We have reasons for using the calculator. 5 to the 2/5 power. Can you do the 5th root of 5? No. So it says plug into the calculator. Let me show you how to use a calculator to type these in. So here we go. 5 to the 2/5. There's just one caution that I have here. Don't type it in like this, because that is 5 squared divided by 5. If you want to type in 5 to the 2/5 power, make sure you put, oops, not that. Let me just retype it. 5 to the 2/5. Put 2/5 in parentheses. 1.903. So we'll call that 1.90. You okay there? The next one is 18 to the 4/7. You do it the same way. No use in me doing both of those. Something like that. Laws of exponents. Again, hopefully you remember most of these. I'll do one example of each, just to kind of remind you. We should have. I agree. I'll make myself a note next year to do those first. It makes no sense why it is halfway. X squared times x to the third. If you remember what this stuff means, it helps with your laws. This is 2x's times 3 more x's. So you have x times x times x times x times x. Right? So x squared times x to the third is x to the 5th. You don't have to remember the rules if you remember why they work the way they work. X squared raised to the third power, a power raised to a power. There's the two that people get messed up. If you remember it like this, you can actually use this rule to evaluate this. Because x squared to the third power is the same thing as x squared times x squared times x squared. Now using your first rule, what is x squared times x squared times x squared? X to the 6. So what's the shortcut? Power to power, multiply your powers. Yeah, if you have like bases, different exponents, you add them up to find out how many x's you have. And really you're doing the same thing here. To find out how many x's you have 3 sets of 2 x's. So you have a total of 6 x's. Division, x to the third over x squared. And this is kind of funny because we've been using this already this book. You have 3 x's on top. You have 2 x's on bottom. The reason that works is because these cancel each other out and leaves you with x to the first on top. If you have more on bottom, x squared over x to the third, your leftover is on bottom. Makes sense. I don't like the whole subtraction, like 2 minus 3, that's x to the negative 1. I don't like that. Just look, there's more on bottom, so you're left with stuff on bottom. Let's see, what else do we have? Powers to powers. You have products to powers. Like if you have 2x raised to the third power, what's for being raised to the third power? To both 2 and x. Why do we not have to FOIL there? What one thing is missing that makes this not a FOIL type problem? Plus or minus. That's a monomial. If that was 2 plus x, we don't like those because you're going to have to do 2 plus x times 2 plus x times 2 plus x. But since it's just 2x, we do 2 to the third, x to the third, which is 8x to the third. Any questions? If it's being multiplied, just raise each to whatever power. Division works the same as that. If you have x over 2 to the third, that is x to the third over 2 to the third, which is x to the third over 8. So multiplication and division works the same way. The last thing I want to discuss is negative exponents. Hopefully you remember them. 2 to the negative 3 power. This is probably one of the only things that you would have forgotten. Do you remember how to make a negative exponent positive? Yeah. Put a fraction bar under it and flip it. So it comes to the bottom. On bottom it's now 2 to the positive 3. What's on top? Put a 1. So 1 over 8. What if it's on bottom though? What if you have 1 over x to the negative 2? Put it on top and it becomes x to the positive 2 on top. Well, you have a 1 on bottom, don't even have to put it. The only other trick that I want to remind you of, if you have a fraction raised to a negative exponent, you remember a shortcut for doing that? You could actually go back and use this rule and raise 1 to the negative 2, raise 3 to the negative 2, move them and all that, but the easy way, whatever's inside fractions, flip it. 3 over 1 raised to the positive 2. So that's going to be 9. So a fraction to a negative, flip the fraction. A single number raised to a negative, bring it across the fraction bar, makes it positive. That's a really quick review of all that. Now let's go to some ugly problems. Example 4. We're already nearly finished for the day. The square root of x to the 7th times x to the 5 halves. Thank you. Okay, you have a mixture here. And this goes back to the problems we just talked about. You have a mixture of square root symbols and fractional exponents. Write them all the same way. The square root of x to the 7th is x to the 7 halves. Make sense? Times x to the 5 halves times x to the negative 3 halves. Now you just use your rules. If that had been x squared times x to the 3rd times x to the 4th, what do you do with your powers? You add them. And that's what I do. I take a problem like, when I have to work that, I take a problem that looks easier and I say, okay, what do I do with my exponents there? I add them. So here, you're also going to add them. 7 halves and 5 halves is 12 halves, minus 3 halves is 9 halves. Any questions? X to the 9 halves power. You can leave it like that, or let's clean that up a little bit. Write that as the square root of x to the 9th, correct? Same thing, which is the square root of x to the, we can't find the square root of x to the 9th, but we can find the square root of x to the 8th. It would be 4.5 because of this, 9 halves, right? The square root of x to the 8th times the square root of x to the 1st. You can split it. What's the square root of x to the 8th? Times x, the square root of x. You can write it either way. This actually looks better on this problem. Yeah, that's right too. And you could type that in your calculator as that. You could do x to the 4.5 power and it will give you the same answer. Because 9 halves. 9 divided by 2. All those are equal. Next one, 7a squared. Cody's photographic memory is not working on this one. 5b to the 3 halves. I'll see how you remember that much. ab to the 1 half. I have to do one little piece at a time. And bc to the negative 1/4. That's pretty ugly. What I would do, get rid of all my parentheses. So first set of parentheses, 7a squared. What is that? 49 a squared. Just square each piece. Next parentheses, 5b raised to the 3 halves power. Anybody know off the top of your head what 5 to the 3 halves power is? Probably not. 5 to the 3 halves times b to the 3 halves. Power, or a product to powers, just raise them each to that power. The only reason I went ahead and did 49 is because I knew it. On bottom, what would you have? A to the 1 half, B to the 1 half, B to the negative 1/4, good, and C to the negative 1/4. Just get rid of all your parentheses first, because you can't combine anything until you do. Now let's start putting A's and B's and C's together. We can combine on bottom. I know we can put those together. And I've got B to the what? 1/4. That is right. Well, let's go ahead and do that. So on bottom, we put those together. I got B to the 1/4. Let's go ahead and put these together. Let's talk about how to do that. And we'll do just a small piece at a time. A to the 1 half on bottom, A to the 2nd on top. You've got 2 A's on top, and you've got a half of an A on bottom. So before you're able to do that, to find out how many more A's you have, because it's easy when you have A to the 3rd over A, because then you can say, well, you've got 2 more A's on top. What you're going to have to do, you're going to have to change this to 4 halves, because 2 is the same thing as 4 halves. Now you can find out you've got 3 halves on top, which is 1 and 1 half, like you said. Still got a 49 up there. You still got 5 to the 2/3. I don't know what we're going to do with that. And you've got B to the 3 halves. What about this? C to the negative 1/4. What can we do with it? Is it 3? Okay, thank you. I was just making sure. What you're going to do is c to the negative 1/4. Don't leave it. Flip it. Bring it to the top. C to the positive 1/4. Right? No. No. You could. And actually change it to a decimal. I think that's what we're going to have to do with it. Because there's nothing that it'll combine with. There's only one other thing that will combine. What is it? My B's and my B's. And like Brittany said, we will put these together too. The 49 and 5 to the 3/2. Got B to the 3/2 on top. And you've got B to the 1/4 on bottom. Let's change it to where the bottom's the same. 3/2 is the same thing as 6/4. 6/4 on top, 1/4 on bottom. You're left with 5/4 on top. So you have 49, and let's do this on our calculator. Let's go ahead and put 49 and 5 to the 3/2 together. 49 times 5 raised to the 3/2 power. 547.84. 547.84. B to the, well, let's do them in alphabetical order. A to the 3/2, I wouldn't be able to handle that. B to the 5/4. C to the 1/4. Man, that's nasty. If you wanted to write this, for those of you that are particular about this thing, if you don't like these fractional exponents and you wanted to write as one big 4th root, you could. But the only problem is this isn't to the 4th root. You could change that to the 6/4. You could do A to the 6/4, B to the 5/4, C to the 1/4. If you just wanted to clean it up, now it's all to the 4th root. So you could do the 4th root of A to the 6th, B to the 5th, C. That looks a little bit better. You could do that. You'd put it out front. Yeah. 547.84 times the 4th root of A to the 6th, B to the 5th, C to the 1st. Questions? That's the biggest thing today's lesson is just learning to manipulate these. If you can use your rules for exponents on these, you know your rules for exponents. Because you don't have whole numbers anymore, you've got fractional exponents. Next up, another one that looks about as equally junky. A to the 3/4 B to the 2nd power, AB to the 1/4 to the 3rd, over AB to the 1/2, or my own, yeah. BC to the negative 1/4. Is that right? Is that the problem I just worked?